Okay, welcome. So in the last talk, Steve said, don't worry about it. This talk is not that talk, okay? He said, relax. This talk is not that talk. Pay attention, okay? And ask questions, preferably during the talk, if there's any part of it that seems hard to follow. Okay, worry about it. Worry about it. Keep that in mind. Okay, with that.
Okay. So, hi, I'm Nicole. I'm a software developer and a software development coach. And I'm working with multiple technologies like object orientation, also clean code, software craftsmanship, domain-driven design, and so on. And also especially functional programming, which we might turn to a little bit today.
Yeah, my name is Mike. I'm CEO of a software company in Germany called Active Group, and we do functional programming every day. We write 0 lines of code in Go or Java or any of that other stuff. And we also run a fun developer conference, almost better than this one, in February in Berlin.
So, when we're thinking of software, actually the most blatant situations where we are aware of software is when it fails incredibly. So maybe you remember this is like 1 and something year ago where there was a botnet taking over all sorts of embedded devices, and for us most relevant was maybe that actually GitHub went down based on this, and so we couldn't interact with GitHub anymore. And yeah, so this was a big disaster back then. All sorts of fridges and whatever were just turned into bots that would attack sites, and yeah, this was a big disaster.
Okay. Anybody remember this one a couple of years ago? You may not have been born then. So in Germany, this was on the news. Was that on the news here? So it was a German programmer introduced a vulnerability into OpenSSL, which turned out that pretty much any web server on the planet, if you asked it the right kind of question, it would divulge secret keys and passwords through a buffer overflow that was in the software.
Yeah. And I think like last summer, we had this amazing attempt of Cloudflare to actually spread out passwords and all sorts of important and secret information to the world. You didn't even have to hack the site. The site would render this information into the web page that you were looking at. So there was not even, you wouldn't even have to use any special techniques to get at this private information from the site.
Anybody remember this? Notice that? So there was some incorrect handling of headers, which led to a code injection vulnerability in Struts, a popular web framework, that led Equifax, a very powerful provider of credit information in the US, to divulge essentially information about all of its clients, right?
Yeah. But what we learned from this, that doesn't bother people at all. They were able to secure this big contract right after this thing happened, and so they were actually being contracted to do fraud detection for the IRS, and that's like sort of, you know, putting the fox in charge of the henhouse, I think.
Unless you're a programmer.
Yeah, and then of course they discovered who was to blame for this, and of course it was this single developer totally down the line, and he has caused this fault. Nobody else, of course. The whole company was totally perfectly fine. Just this one developer was the culprit, and you know.
Yeah, so this might have slipped under the radar for a lot of people, but a lot of cars these days have remote access methods that are vulnerable to all kinds of attacks, right? And if you buy a car these days, there's probably some kind of attack vector that people can use either by plugging into one of the ports in a car, or even remotely, right? This is from a big DARPA project that was investigating this set of vulnerabilities. So don't worry, is that the right approach to software?
So what can we do about this? What do you think what we can do about this? Not use it. Well, you can't avoid. If you happen to buy one of those cars, then it's just in there, and you can't say, okay, I'm going back to a tricycle or whatever, you know, and pedaling my way to the office. Doesn't work.
Probably you have to raise awareness between developers and maybe enforce them to use some particular security things.
You have to raise awareness. That's a very good point.
Change the incentives people do.
Change the incentives, yeah. So usually people give us this answer. Huh? What?
One more.
Ah, okay. Sorry. Give us this answer. Of course, we need more tests, right?
Yeah, well, so, no, somebody.
Oh, sorry.
Well, the thing is a lot of the time it's like you're using open source projects and stuff like this, so it's not coming directly from your code. Like that's why there's like botnet spreading. You're all using the same library. You're not going to test this thing because it's like some third party.
Yeah, but why did this get into the library in the first place? That's the thing we need to worry about, right?
Yeah.
Like Heartbleed, it was in that library.
Yeah, and as a client of the library, what would convince you that it's not vulnerable to this kind of attack, right? So, well, you're all, I think most of you are too young to remember this, right? In the 1990s, Intel discovered, or not Intel discovered, a couple of clients of Intel discovered that there was a bug in the floating point unit of one of the first Pentium processors that was shipped, and it caused, and it forced Intel to actually recall that particular line of processors, and it caused several billions of damage to Intel itself. They recovered some of that damage through then selling the processors in different formats that they had to recall, right? Now, Intel did a lot of testing, as you can imagine, of their processors. In particular, a typical floating point unit at the time had a test suite of something like 20 million tests, okay? And they didn't catch this particular bug. So,
Yeah. So there might be another answer to this, and maybe this is we need better types. What do you think about that?
so Nicole would say that because she loves Haskell, right?
Yay!
So who else in this room loves Haskell? Ooh.
Wow.
Oh, okay. So who knows?
He's hiring.
Who's hiring? Who's written a Haskell program? Okay. So that's not everybody. So I can show you how that works. So it just takes a second. So I'll show you. So Nicole believes that types are going to fix the problem. I'm going to show you that that actually is not. It's probably not true, right? So. Okay, so a lot of you have not written a Haskell program. We should probably start. So Haskell programmers and generally functional programmers, they deal a lot with a data structure called a list, and that has a specific meaning in functional programming. And so let me write down the definition of list, even though it's built in, but we'll just write it down. And it looks something like this. And I'll explain it, of course, but let me write it down first. So we all know. So this is, you might say it's a singly linked list or something like that, right? So what this definition says, there's two different kinds of lists, right? One kind is the empty list, often called nil, right? And it has list A for any type of A of elements that you might imagine, right? So that's the first line in that definition, right? The second line says, well, those two colons are usually pronounced cons in functional programming. And they say, well, if you've got an element, that's the A. I think we should probably point it out like this. So there's A here. So the A here means you have one element. That's going to be the first element, and you have another list. Then you can put that element in front of that other list, and you can create another list that has that first element and the rest that you passed in. Okay. And of course, lists are, well, you wouldn't do that in Go, but in Java, you all know generics. So that's what that type arrow type thing at the top says. It says that lists are not a type sort of by themselves, but really they are a type constructor. You talk about lists of elements of a specific types and not of lists as some separate entity. Okay? So that's essentially the definition of lists in any functional language. In this case, it's written in a language called Idris, which we've chosen to use for today, which is very similar to Haskell. If you're a Haskell programmer, you need to mentally switch single colons and double colons. That's the main thing that you need to do. So Idris has this thing. Well, we can write a function. We talked, so Michael Feathers talked a lot about maps this morning, so we could write a map function on lists. Okay, and the map function says, well, we have a function that goes, well, maybe you should read it from here. So we have a list of A's, right? Some kind of A. And you have a function that takes you from 1A to 1B, right? You pass in. So that's what that arrow says in the, up here, right? You have a function that goes from A to B. You have a list of A's. And if you have both of those things, you can make a list of B's by simply applying the function to every single element of the list and making a list of the results, right? Now, ideally, yeah, so Nicole just pointed out that this is built in, so I'm just going to comment that out.
Yeah, otherwise it gets totally confused.
Otherwise it probably will. Anyway, so Idris is this thing. It has, so that's why it's great for talks, is you can push a bunch of buttons and it will write code for you, okay? So I can push a button and it will write, so that was the type declaration. And Nicole's theory is that the types will make my programs correct, right?
Yes.
And so I can push a button and it will generate the first line of a definition for the map function. That's that equation. And, well, we've seen that there are two different kinds of lists, right? There's the empty list, and then there's the non-empty list composed of the first element and the rest of the elements. And so in a functional language, that means you need to write two equations. And you can push a button, and it will write both of those equations for you. And it says, the first case says, well, let's say you have a function f, goes from A to B, and an empty list. And the second, you could also say nil, but this looks nicer to people. And the second equation says, well, if you have a non-empty list where the first element is x and the rest is x's, then you could write something down here. And Idris just puts a template there, and we could now write some code. But the thing is, if you've got a template there, you can push another button, let Idris figure out the code for you, right? And that looks all right, right? If you apply a function to all the elements of an empty list, you get the empty list again. And if you push a button here, oh, it says, well, you apply a function to a non-empty list, you get back the empty list. So this function definition is incorrect, but I can load it into Idris. The type checker will say, oh, everything is wonderful. So it didn't prevent that particular kind of mistake.
So I
Nicole.
think you know a lot about lists and
Yeah.
all this kinds of stuff that you very neatly explained. But I think you overlooked one thing, and that's we need to give it good and meaningful types. So if you say, okay, whenever I apply a function to any sort of list, and then I will get any sort of list back, then Idris, in the generation phase, is totally lazy and says, I will give you the simplest thing that could possibly work. And if you're just expecting a list, then the empty list is the simplest list. And so it can't give you more information than that. But instead of list, you can use a much nicer and much more, much richer type, and that's a vector. And I can show you how this would
So
work.
my
then.
types are not expressive enough?
Yes.
Well, you show us.
Yes, I show you. So, as I said, we have a data type vector, and that now takes an integer and a type and returns a type. And now we have basically the same thing here. Another question is, what does this weird integer do there? Well, the integer actually describes the length of the list. So we have one type for all the lists that have length 0, and one type for all the lists that have length 3, and one type for all the lists of length 427, say. Okay?
So the integers, that's that nat thing that you have there?
Yes, exactly.
okay.
Nat is another way of saying integer, positive integer,
Okay.
positive or 0. And so, if we want to describe the type of the empty list here, that would, of course, be length 0 because it's empty. And now, if we define our cons operator, and we say we have an A and we have a vector of length n, we don't know exactly, but let's call it n, then of course the result will be of length n plus 1. Okay? Does that make sense so far? If not, please ask, because this is not getting simpler. I think you got that by now, okay? So, and now, of course, if we define our map function again, I'm using a different name now, so I'm calling it map v. And now we say, okay, we give it an n element vector of type A, and now if I apply the function to all elements in the list and create a list of the results, then what I want to have is that the length is the same, right? I don't want to lose any elements, and I don't want to invent any elements on the go. And so my result here would be a vector of length n with elements of type B, because I just transformed them with the f. Okay? And now if I start pushing some buttons, I can say, give me this function, and now also make a case distinction. I need to go a bit further down here. Now make a case distinction on our vector. So we also have the two cases here, nil and the cons. And now if I ask it to solve the map function, then here you will see for the empty list, again we get the empty list because it knows empty list is of length 0, so it can only provide me the empty list because that's the only element it knows that is of length 0. And here, looks better to you?
So it's not the empty list anymore, right?
No, it's not the empty
so
list anymore.
So it says, well, we're going to apply f to x, right? We're going to apply, and x is the first element,
right?
And we're also going to call map v recursively on the rest of the list. So now we have, okay. So now we have one thing that's of type B, right, which is f of x, and we have something that's of type vect. Well, sort of n minus 1 or something of b's, and we can just cons those two things.
Yep.
Oh, and then things just work out.
Yeah.
So when it does that because this is like the simplest thing that will have the correct type.
Yes, exactly. So there are other solutions, of course. So you can have permutation in this.
Mm-hmm. Oh, but that'd be hard to do, right?
Yeah, that would be hard to do, and so Idris is lazy, as I mentioned, like me. So it just gives you the simplest solution that matches these types. And that actually happens to be what I would also expect a good solution to be for map. I don't want permutation in there, right? So we have A and B are generic types, and we have no idea how we could create an element of type B, because B could be anything, you know? We don't get a constructor for B. And so the only way to get to a B is by using F. And so, you know, then we have a B, and then for the length we get this sorted because we know that the tail is one shorter than the whole list, and then everything lines up again very neatly. And that's what you can get when
well, I gave you
have
this
good
very simple
types.
example, right?
Yes, of course.
So let me.
You gave it to me.
Well,
so.
you get up. Let me do something else. So let's say I want to let's do something that I think is going to be a little bit more difficult.
Sure.
Here, people, it's going to be more difficult, people. So if you can figure it out, you tell me.
Yeah. And do worry.
Yeah. So the idea is, so I'm going to use your fancy vector type.
Go ahead.
And see if that's going to help with anything. So the idea is, well, I want a function that takes an A and it looks up if that A is in the vector, right? It says, right? So I write this type signature, and it just says yes or no. Yes, it's in the vector, and no, it's not in the vector, right? Mm-hmm. So I push a bunch of those fancy buttons. And again, I know there's two different kinds of vectors, just like there's two different kinds of lists. And it will split those up, and it will have one equation for the empty vector, and it will have one equation for the non-empty vector. And now, again, I go through this rigmarole of pushing a button, looking for the simplest solution. Simplest solution seems to be false, right?
There's nothing in there, especially not X. So that's correct.
Yeah, so if I do that again, it's false.
So
how do I... So, I mean, there's no vector coming out, so how do I put more... There's not enough in the types, right?
So did you listen to anything I told you over the last 5 minutes? You're doing the same thing all over again. You're using a stupid type. You need to have more intelligent types. You need to have more information in the types.
Okay. Yeah, well.
Let me show you. Okay.
I picked the wrong example again, I think.
Yeah, the same example all over again. It's always the same. It's like Groundhog Day. All right, so if we just say, yes, it's in there, no, it's not. Okay, you could believe that, or you could think, maybe it's wrong. So that doesn't help you. if you really want to trust the result of this function, you need to get some sort of proof that you can then reproduce and use to verify, yes, the result is correct, right? And that's what we are doing in our types. So our type will contain a proof of, yeah, it's actually in there. And
She said proof, right? Who hates math? Oh,
wrong conference.
yeah.
Okay, so let's define a data type. I call it position because it gives me the position of an element in a list. Okay? So we have an element and we have a list. Of course, this is my vector thing. So, and then there are two possibilities for an element to be in a list. So either it is the head. And what does it mean for it to be the head? If I call this element x, then I must have a list that, hey, that goes like this, right? So the list starts with the x I am looking at. Okay? The other option, of course, would be a tail. So given I know that my x is in some list axis, then I also know that whenever I tuck something onto the front of this list, then it's still in there. It's just one step further down the list, but it's still in there. It doesn't disappear just because I tuck on something to the front. Okay? And so now this is a type where you can actually get more information out of your isElement thing. And just for a moment, I will play around with this a little bit, because as you can see here, and this is really takes a while to sink in. So this head thing doesn't take any arguments, for example. So usually I would have expected, like years ago, that I say, okay, I have an object or a data construction that says head of a given list is this element. But then we're in the program space, in the code space, and we can write anything there. So we need to construct our types so that they only contain the correct elements. And that's what's happening here. And for example, if I say, let's say I have a foo, and that is of a type position of x in axis, and if I now go ahead here and create this, and if I want to solve it, then it can't give me an answer, because it doesn't know anything about the axis here. You see? Now it says foo RHS 1, and if I tell it to resolve, then it just gives me another one. So it can't get anywhere. What I have to do is I have to actually make the type here more precise and say, I'm talking about a foo that is of that type, position of x in a list where the x is at the start. And if I now resolve this, then it just can tell me, yeah, that's the head. And I can even be more concrete than using axes and stuff. I can even use concrete values, which is very interesting. Jesus, where are they? There, right? So if I have something like this, and I tell it to resolve that, and it can immediately tell me, yeah, it's deep down there, but you will find it eventually.
But Nicole, this thing, like the colon thing, right? That's the type declaration, right?
Yes, that's the type declaration.
But it has like values in it.
Yes.
Right?
So that means we can make our types much, much, much smaller.
So,
So
should I
this
try to
type just
should I even try to understand this right now?
maybe better not.
Okay. So understandability is like overrated, right?
Yes, exactly. Okay, so this is how you work with these things. I always imagine a type to be a set of all the elements that match this type. And here, if I write something, position of 1 in this list, then the type that is described by this just contains this one element that it now gives me here. You know, so I have much more flexibility and I can define my types much, much, much more fine-grained, which helps me find solutions automatically.
Yeah, I want to play with this. Go, go.
Yeah,
go.
do you think
Okay.
you can
Yeah. So
try this out?
So the idea is I don't give back just yes or no, but I give back like a proof if the element
Yes.
is in there, right? Is that the idea? So then the thing is, well, I need to write something here, right? So there's a position of some, well, of the thing that has, I want to put the thing there that has type A, right? And the thing there that has type, can I do this? Like,
Yeah, you
Oh.
can give it a name.
oh,
And then you can refer to it.
oh,
in
okay. So I could
subsequent parts of the
do
type.
this, right?
Yep.
But, okay, so I can give back a position, but what if there isn't one, right? If the element is not in the, well, I can do this maybe thing, right?
Yes.
Oh, yeah. So that is if you've programmed in Haskell, or if you program in Java these days, right? There's a type called optional, and Idris has the same thing. It's just called maybe. Either it has either there's a value or there's not a value. So we just write maybe there's a position, and maybe not.
Yeah, maybe
right?
not.
Maybe not.
Because you
okay.
don't know.
Okay. So well, let's start from here. See if we can make that work. Okay. So again, I can have one equation be generated for me. I can push that button that generates 2 equations for the 2 different cases of the vectors. And now I could go, well, so in this case, I guess it says nothing, right? Which says, well, there's not a proof that the element is in there. So in this case, the answer is kind of it depends, right? Is element. So
Yeah.
so and if the way you write is depend in this funny language is you write a case expression, which is like a switch or something in Java. And so really what I want to do is, well, in order to do this, I need to compare like the first and the second element, the x and the x with the first element of my vector, right?
Yeah.
So I write it like this, right? So wait, so let's see. Oh, when I do this, it generates like a tiny error message, right? And it says, let me make that bigger. It says can find implementation for EQA. That's because I try to compare x and y, right? So I try to compare x and y, and that doesn't work for all the values in this language because you have functions and there's no general way to compare functions, for example.
Yeah.
So in this case,
And
I
you
need to
need to
write
make-
down that this only works if A is a type that supports comparison. Right? Does that make sense? Okay, so now I can again push another button, see if I can figure out what this case value should be. So x equals y can be false or true, right? And in case true, I want to return one of these position things, right? And since I'm in a maybe, I need to write down, well, there's nothing, and then there's just that one value. Well, that's all right.
Yes.
Right? Because if
So-
it's true, it should be head, right? Because it means that x is indeed the first element of my vector. It should be this head thing that's there,
Yep.
right? And it says, and that would be the simplest thing also. And it says, no, it has to be tailed as something else.
So
why
I
is
wanted you to bump into this because you wouldn't have believed me anyway if I had told you up front. But here, of course, you're doing the same thing, right? You are just saying, yeah, false or true. So what does that mean? We don't really know. We need to construct types that give us better information.
You're saying I made the same mistake twice?
Yeah, third time
In
now.
public?
Yes.
Okay. So let me see. So this kind of, so here you kind of encoded that this thing has to be equal to that thing, right? The x has to be equal to that other x that's there. So maybe we can use the same trick for, we're trying to do something easier, right? We're just trying to see if 2 values are equal, right?
Yes.
So we could write something, we could also do like a proof of that, right? We could do like an A, then there's another A, and then there's a type that contains the proof. And I could say two things are the same if, well, if I can write like this thing and this thing here, just the same letter twice, maybe I could do that here. Does that work?
I knew you would get to it.
Well, I shouldn't try to understand this, right? Okay, yeah, okay. Well, we'll just, okay. So for simplicity, we're just going to assume that there's like an operation that's going to do the comparison.
Yeah.
That would be a little bit more involved, I think.
Yeah.
So that says, well, I've got an A, I've got another A, and it yields, and it should give me it should give me a proof if those two things are the same, right? And in order to talk about that, I need to give them names, right, like I did here. So I need to say, well, there's an X and there's a Y, both of type A, and maybe it's going to tell me that X and Y are indeed the same. So an iter is kind of neat because it allows me to just sort of leave that type definition, that type declaration there, and then we can go and play with that. Okay. So now we should just ditch this, right, and kind of do and use.
Yeah, and I think you can ditch the equality constraint as well.
Okay, so we can get rid of that. So what does it say? It says a case, and then instead of that equal thing, I do this maybe equals thing, right?
Yes.
And I compare x and the y, and now it says, well, nothing, and then it just says just x. So in this case, this x is like a proof, right? That x and y are the same. It's kind of stupid that it called it x,
Yeah.
right? So, but I can push a button, and then it says, well, funny thing, this equals thing, and it has like, it has only that one thing in it, right? It says it must be same. There's only one case in that data type declaration. So I know that if the first element if the first element is the element that we're looking for, we know some just thing should come out. And now, I could push a button, and it says, it says head. That's kind of, okay.
Yep.
So now, but here it's kind of tricky because if the first element is not equal, then it might be in the rest, right?
Yeah.
So we need like a
Or
recursive
not.
call, and then figure out what comes out of that. So we need like a recursive call here, and and then I need to sort of do the same thing here, which says, well, if it's just x, that means, well, it's in the rest of my vector, right? It's not the first element, but it's somewhere in the rest, so the answer should be just something. And maybe we should call that proof and not x again. And I can push a button. And it says, well, if there's a proof that it's in the rest, we can sort of transform that proof that it's in the full list by just attaching one tail to it. Okay. And in this case, well, I guess I can push a button. It says nothing because, okay. That's pretty neat. Okay.
I knew you'd
so
like it.
I just push a bunch of buttons, and I kind of guess what the outcome should be, and then, well.
Yeah.
Okay.
So actually, I'm not sure if you're aware, but there is like the other direction still missing. Because now what it gives us, if it gives us a proof, then we know there is a proof. But if it says there is no proof, then we must make sure that there actually is no proof and that it's not lying to us.
Whoa.
Right? You get that? But I think we're a little bit out of time, so maybe we can release the audience here. And
No, they all want to see this, right? You all want to totally see this. Okay? Well, did you hear that? Is that, like, does anybody have any questions so far? Huh?
there you go.
What? Why is she doing it to you? Well, I mean, you got all this warm fuzzy feeling from testing and understandability this morning, right? These people tested and they thought they understood their code, and somehow that didn't help them get it correct, right? So I can assure you, I just pushed a bunch of buttons, right? Isn't that every software developer's dream, like pushing and it just kind of writes itself? Yeah.
I'm just interested, how is this going to help you on like such a low level, like buffer overflows and hardware faults? This is all very nice and fuzzy. If you're I'm too stupid to understand, but It's all very theoretical, right? And does it apply to like real problems?
This is not theoretical. This is actual code that
Yeah, so
actually
you want
runs
to-
and that actually does these things. And it does the mapping and it does the finding of the element in the list. This is the very, very low level code that you are looking for.
But
And this is correct code.
yeah,
other
but to
than-
me it's also Chinese, and I don't speak Chinese. I mean, I find it very, very difficult
No,
to
but the great
understand.
thing, the great thing is you can push a bunch of buttons. So
You're really getting the hang of that,
yeah,
right?
yeah, I'm totally enjoying that. So
But, yeah.
yeah, so you got, I mean, so maybe we'll shelve that idea that you had, that nifty idea where you would, so maybe you all noticed that in this code I still could have written nothing everywhere and it would still have type checked. So, so the converse direction would have required a little bit more work, which we'd love to torture you with, but there's more questions.
Just a quick one. So this is a very neat combination of Prolog and C++ templates, but
Yeah.
where don't you find that it actually kind of transfers your thinking from code to types, but you still have to think
Yeah.
about types and write the types, and you still can
Yeah.
make human mistakes in defining your types, as you did 3 times
Yeah.
already.
Yeah, good
Like,
point.
does this save you from the bugs if your types are wrong?
So, should I say something?
So I think the compiler has a much better grip on the types than it has on the code in terms of semantics and how things play out. I mean, this actually is a very experimental language, as you can tell. So this is nothing I would write my production system in right now, but I think it's worthwhile thinking about and exploring and also seeing, getting experience in, does this really solve our problems, or is this just a nice layer? So I totally believe in this, and I think this is the way to go in the future, if only for very specific tasks, like today, you use specific languages for specific tasks. But I think it's really a really valid approach.
Oh, and it's the talk is called the day after
Exactly.
tomorrow,
So
right? So,
don't expect
so you
solutions
can do
put
it
in
with C++
production tomorrow.
templates. Go just do it somewhere else. But we got a bunch more slides, so we should get to that
Yeah.
because it answers some
We
of the
just
questions
want
in more
to,
detail that we've had. And
Give a quick wrap up.
yeah, just let that come up for a second.
Uh-huh.
So in fact, there are some systems that use this approach to make
Yes.
their code correct.
So there is a C compiler, and that has actually been proven correct. So not with using Idris, but with using like standard verification methods. And so this compiler is guaranteed to produce code that actually does the same thing as you intended when you wrote your C code. And this is a French project, and I think it's already quite a couple of years old, so it's not new things we're talking about here.
No, and to answer your question, right, is that approach actually going to generate a more correct C compiler? So there's all kinds of studies on the correctness of C compilers with fuzzing and all kinds of other approaches that are independent of this proof aspect, and these approaches have not been able to break Corsair, and they've been able to break all other C compilers. So the empirical insights suggest that indeed this generates more correct code. So I don't know if people are aware, a lot of phones run actually somewhere on the phone. They run something called SEL4, which is a fully verified microkernel, which has proofs for things like isolation properties and things like that are important in a kernel like this. We're verified with Haskell and with Isabelle, so also with tools similar to the ones that we've shown you. I'm sorry, I stole your slide.
No.
Yeah.
Perfect. All right. Yeah, and then AMD also actually learned from the Intel disaster we mentioned previously. And so they actually used a theorem prover to verify their floating point engine, which I think was probably not an easy task, but they invested the effort and got there and got a fully verified floating point unit in the AMD processors.
So,
Yeah, and as we already briefly mentioned, there's a bunch of tools that are available. Theorem provers like Koch and Isabelle and ACL2. And then you have languages like Idris, which we showed you, Agda, which is also very similar, and F star, which is a more rigid version of F sharp, which has also more information at the type level. And then there are also some works going on for Haskell, like this liquid Haskell or dependent Haskell, to have this thing, which is, by the way, called dependent types, so that you have types that depend on other types in your function signature, to also bring this directly to Haskell as a language extension. So you don't have to learn this or use this weird Idris stuff. You can use something that's already industry proven.
Okay. So in case you didn't notice, this all has to do with functional programming, continuing the theme of this morning, which makes it much, much easier to construct proofs like this, in case that wasn't obvious. And this stuff is also eminently teachable if you're worrying about training for this. So one thing that you might look up is the program by design approach that gets you into functional programming if you're not in it already.
Yep.
All right. Thank you very much.
That was it. Hope you enjoyed it. So we may have 2 more minutes or so for questions.
Yeah, probably 1 or 2 questions. Yeah.
There is one.
There you go. Okay. I was curious what the compilation time looks like, or for lack of a better word, like what's the feedback loop when you're writing like a serious program, like, I don't know, 20,000, 100,000 lines of code? Is there significant impact when it comes to compiling this type of code?
Do you have any experience with that, large scale?
It's kind of difficult to answer that. I mean, functional programs rarely get to 100,000 lines of code. That's first of all. I mean, compilation time is significant, but I mean, you saw this is one interactive environment for this particular type of language, and it's not instant, but it's pretty quick as you're writing a single module. More sort of, I mean, there are tools in this space, like Isabelle, for example, which have a much more advanced sort of IDE-like interface, which is incremental. So I don't think sort of the answer to that question is going to really answer the question underneath, which is what your development and experience is like. This really is, this feels like a completely different thing from writing a bunch of Java code, right? So it's kind of hard to compare that just by looking at compilation speed.
Hi. I like the talk very much, not only because of the content was nice, very nice, but because of the style. I really liked your couple arguing in the kitchen approach. I found it very refreshing. But
Thanks.
Back to my question. I would like to understand what's your point here, because there are 2 possible interpretations I see out of this. The first one is we need to make safer code, better code, and stronger types, static types, Haskell, Staffy will help us to make better code. That's one possible interpretation of what you have said today. The second interpretation, which you hinted at times, is what some people say, that we just need really, really good types, and then we don't need any more code. We just define the types, and then the computer will do everything from us, which, of course, some people argue that there's no such thing as a software that is only defined by these types. There's always behavior that you cannot define by the types. And it wasn't clear to me which camp are you on, so I would like to know. Thank you.
We deleted that slide, right? Like right before the talk, right? That was the answer to your question.
So I think it's both, right?
Yeah, well, it is both. I mean, the point is, I think I would like to refine your second answer, right? Which is that we should think about not just sort of what our program does on an operational level, but also what properties our program has, right? I think maybe if you want to take like one important message that you can really apply to today's programming, it is that, right? Is you should think about properties, and the right programming language lets you write those properties down right? And the languages after tomorrow will allow you to verify them, or even allow you to generate code from the properties once you've written them down, right? So what you can do today is you can think about general properties that your program should have. You can actually today work in languages that let you write them down. Those are mostly functional languages, but there are some, if you look at QuickCheck, for example, that is making inroads in a lot of other languages as well. So the next step up from there is to automatically test that those properties are fulfilled. I mean, but the important thing is really to be able to write them down. Once you can write them down, your thinking tends to expand, and you tend to think about more things once you have the language to write them down in. The next step up from that is to prove that the code that you've written manually actually has the properties that you wrote down. And the next step up there is to generate parts of the code from the properties themselves. Right.
I would like to actually also extend this in the other direction, not to step up, but also to step down. Because like what Mike said is totally true. Use Haskell or any language that has a good, strong type system, and then it's much easier for you. But then you can go like, oh, I'm working in Java or whatever, C++, I don't know. So this doesn't apply to me. Yes, it still applies to you, because even in those languages, you can start thinking about your types, and you can make your types better. And if I see a function that has 5 arguments that go like int, string, double int, then of course this will have some bugs. Eventually at some time, maybe not each of them, but some of them at some point, And if you just have some better types and clearer descriptions, it's easier to understand. You start thinking more in this world of types, and you can already shift a lot of this burden to the compiler, because it will verify that that int is actually person ID, and that other int is actually the number of euros it costs or something, And then you can distinguish these things, and you cannot mix them up anymore. And this is already possible in any standard programming language that uses types.
I think actually we're probably okay.
One last one. Maybe a comment.
Okay. You can also catch us over lunch, so that's not a problem.
Just follow up from the previous question. So the main kind of the point here is you're able to write safer programs, and you don't need tests, or your tests will be different because you still need to write tests for your programs.
Yes. So the tests will be different because you still need to validate that you got the semantics correct. You can write a type, and then the type doesn't
exactly
mean the same thing.
Okay.
So you need tests, but they are no longer testing like, don't I have a null pointer exception? Don't I, get something wrong at that level?
Property-based tests, and or even different future types of tests.
Yes,
okay.
you are much more thinking in domain terms and semantics than in failures. Thank you.
Thanks.